When one thinks of energy, one thinks of movement. The Greek word for energy literally means activity or operation. In physics, energy is a scalar, physical quantity that describes the amount of work that can be done by a force. There are 7 types of energy, and they are kinetic, potential, sound, gravitational, electromagnetic, including light, thermal, and elastic.
The most commonly known form of energy is kinetic energy. When someone says kinetic energy, one thinks of movement of a ball, a car, a person, etc. Here we see a person running, while here we see a ball rolling down an inclined plane. Both are forms of kinetic energy, which can be described by the formula kinetic energy equals 1/2 mass times velocity squared.
The next type of energy is one that we saw in the previous demonstration as the ball rolled down the slope. Kinetic energy is converted from potential energy, the energy stored within the physical system. Potential energy is stored within the person and the ball when neither of them are moving. As the person starts to run, the potential energy within the person, stored as calories, is released in the form of running. The height of the ball at the top of the ramp gives the ball potential energy, so when it is released, this energy is converted into kinetic energy, which can then be described in the formula potential energy equals mass times acceleration of gravity times height.
Sound energy is a traveling wave with an oscillation of pressure transmitted through a substance. Sound is characterized by frequencies. In our demonstration of sound, one hears music. The sound waves transmit the energy from the source, in our case the guitar, to one's ears. The formula to describe sound energy is Q, sound energy, equals integral of the particle velocity multiplied by the distance multiplied by the surface area. Thermal energy, also known as heat, is the energy that is transferred between two objects with different temperatures. Oftentimes, thermal energy is confused with temperature. The temperature of an object, or how hot it is, indicates the amount of kinetic energy that that object has. Temperature may be used to describe any object at any time. Thermal energy, on the other hand, only exists when energy is transferred due to temperature differences. Thermal energy can be transferred through 3 methods: conduction, convection, and radiation. Conduction occurs when two objects with different temperatures are directly in contact with each other. Convection occurs when heat is transferred by the movement of a fluid. And finally, radiation is the transfer of heat through electromagnetic waves. These 3 processes allow our world to harness the power of the sun.
When you stretch a spring or rubber band, you can feel it pulling back towards its original position. The spring or rubber band is able to exert a force over a distance, which means that it has the ability to do work and also means that it has the ability to store energy. Elastic potential energy is the amount of energy that a spring or rubber band has when it is stretched. Objects such as these also tend to operate in a simple harmonic pattern when stretched and released. There are many practical applications for these instruments, ranging from keeping a pile of papers together to ensuring that a brake will function properly. The kinetic energy of a spring is 1/2 kx squared, where k is the spring constant and x is displacement.
Electromagnetic energy is found in dual waves that have both a magnetic and an electric component. These waves exist because electric fields and magnetic fields do not instantaneously exist, but rather ripple outward from a foci, like the waves created by a pebble dropped into a pond. Thus, if there is a source that generates a constantly changing electric and magnetic field, its influence will create a wave-like effect known as electromagnetic radiation. Electromagnetic radiation is split into several categories defined by frequencies. The electromagnetic spectrum begins with the radio wave and then progresses to infrared, visible light, ultraviolet light, X-ray, and finally gamma ray. The energy associated with a photon is defined by the equation energy equals Planck's constant times frequency.
Gravitational energy is found everywhere. It is the potential for 2 objects to be pulled towards each other. In our demonstration, the satellite shows gravitational energy. The satellite is kept from going out into space because of the gravitational force exerted by the Earth. Gravitational energy is described by the equation gravitational energy equals the universal gravitational constant times the mass of the first object times the mass of the second object, all divided by the distance between the 2 objects.